Eventually it'll start. Okay, let's talk about independent first. So when we're talking about independent, the concept for independent is that you've got two different events that are occurring. Okay, and we want them to occur one after the other. So with independent, you just take the probability of event A and then you multiply it by the probability of event B. There's absolutely no effect. So again, you guys have been doing this right now for all the compound events, just multiplying the probabilities together, because every single one of those events had no effect on the other. With dependent probability, that's a little bit different. You still have the probability of event A, just like normal. Event A happens, and then you multiply it by what we call event B after A. So you have to remove the outcome of event A before you can start calculating the next probability. Something is being altered or changed. Okay, so let's start with some independent practice. So some independent practice. We have a coin and a die. We have a coin and a die. So just like we've been doing, I want the probability that it's going to land on heads and a 6. So we're going to take those probabilities and split them apart. We're going to split it into the probability that it'll land on heads, and then we're going to multiply it by the probability that the die is going to land on the number 6. So the probability that it's going to land on heads is what? 1/2. What about the probability that we're going to roll a 6? 1/6. Okay, and then all we do is multiply those together. That's going to give us 1/12. Okay, this should all seem pretty routine. You've done this already. So I'm going to give you guys a couple of problems to try on your own. Yeah. All right, who can raise their hand and tell me what they got for problem number 2? Let's go with Leona. 1/6 is correct. So let's go ahead and break it down. Got probability of tails is 1/2. Then you're going to multiply that by the probability for a number less than 3. Less than 3 means it can only be the problem, it can only be 1 or a 2. 1 or a 2, so that's 2 numbers out of 6. You multiply that together, and that's going to equal 1/6. Okay, what about for number 3? Probability of tails and then greater than 1. Tails and greater than 1. Go ahead. 5/12. Okay, so the probability of tails is 1/2 times the probability of a number greater than 1. So greater than 1 means the numbers 2, 3, 4, 5, or 6. That's 5 numbers out of 6. 1/2 times 5/6 is going to be equal to 5/12. Okay, and then the last one, probability that it's going to land on heads and a prime number. Heads and prime. Mylin? Not 1/6. Leona? 1/4. So be careful. Prime number. A prime number is a number that's divisible by itself and 1. So it only has 2 factors. It only has 2 factors. It's self and 1. That would be the numbers 2, 3, and 5. 1 is not a prime number because 1 only has 1 factor. 1. The only factor that 1 has is 1 itself. So it does not have 2 factors. Prime means it has exactly 2 factors only. Okay? So here we have the probability for the coin to land on heads, which is 1/2. And then we're multiplying it by the probability of a prime number, which is 3/6, or also 1/2. And then that's going to equal 1/4. 1/4. Okay? Now let's go ahead and start talking about dependent. Dependent. So for this situation, we're going to kind of go back to the whole idea about book reports, right? We talked about writing a book report in a dependent situation. So let's say that we have 5 nonfiction and 3 fiction books. We have 5 nonfiction and 3 fiction books. And we are going to write 2 book reports. That means once you write a book report on one book, you can't write that book report on that same book again. So I want the probability that I'm going to choose a nonfiction book for the first report and then a fiction book for the second report. Nonfiction for the first report and then a fiction for the second report. Okay? So, in situations like this, because it's your first time learning how to do this process, you want to stick to mapping it out first. Before you start just naturally doing it in your head, it's best if you set up a map. Okay, so the first report, and I'll call this round 1. For round 1, when we're talking about our first report, let's start with how many nonfiction books we have. So I'm just going to write non. Nonfiction books, we have a total of 5. And I'll zoom in a little bit more for it. Okay. Fiction books, we have 3. So that means that we have a total of how many books? How many books do we have, guys? 8. We have 8 books, okay? So this is based off of my first round, I want to go ahead and identify the probability that I'm going to choose a non-fiction book. So what is the probability based off of this information that I'm going to choose non-fiction? What is that going to be? 5 over 8. Good. So non-fiction is going to be 5 over 8. Now we're going to go to round 2. In round 2, we have to take one book away from nonfiction. Why do I have to do that? Why am I removing one book from the nonfiction? Why? Because I've already written a book report on a nonfiction book. I already wrote a report on it. I only wrote one report. So I'm taking one away from my nonfiction value, and that makes my new nonfiction value 4. Do I have to do the same thing for fiction? No, because I haven't read a fiction book yet. I haven't done anything here yet. So that's going to still stay a 3. But what happens to my total? My total is gotten smaller too. It got smaller by 1. It's now a 7. Because you took something away, your total is always going to keep decreasing by 1. So now for round 2, I'm going to base my probability based off of the 4 nonfiction, the 3 fiction, 7 total. So what's the probability that I'm going to choose a fiction book this time? Not 4 over 7. I want fiction. 3 out of 7. 3 out of 7. So we're going to choose a fiction book this time. There's 3 fictions out of 7 total. And we just multiply. That's going to give us 15 out of 56. 15 out of 56. Again, it helps if you map it. If you make a little map off to the side and say, okay, well, this is what I'm starting with. All right, now I've done my first probability, so something's getting removed, so here's what I'm left with. Now I'm going to do my next probability. And some of the problems you might have to do it a 3rd round. So it might decrease again. Okay, if I said, okay, well now I want a 3rd book report of nonfiction, well now it would be 4 out of 6. Okay, because I'd still have 4 nonfictions, but now I'd have 2 fictions, and 4 plus 2 is 6, so it'd be 4 out of 6. I'd multiply by 4 over 6. Okay, so every time you do a new round or a new event, your total is going to get decreased. All right, let's go ahead and flip it to page 11. Let's do a couple more problems. All right, there are 11 girls and 8 boys in the class. 11 girls and 8 boys are in the class. We're going to have the kids, or have the students, lining up, right? We're going to go to lunch. We're lining up in the hall. So I want to know, what is the probability that the first 2 students are going to be girls? Okay, what's the probability the first two students are going to be girls? So that's a dependent event, because once a student lines up in spot 1, that student is no longer available to line up for spot 2. They are out of the running, okay? So again, we're going to map it out. We've got two probabilities. We have probability that the first student is going to be a girl. And then we've got the probability that the second student is also going to be a girl. Just 2 rounds. So mapping it out. I'm going to just put R1. Does everybody understand that R1 represents round 1? Okay, good. Abbreviations are always helpful. So for round 1, how many girls do I have in round 1? 11. I'm starting off with 11 girls. How many boys? How many boys are in here? 8. So then how many total students are there? 19. 19 total students. Okay? 8 boys, 11 girls, 19 total students. So the probability, based off of what I've got right now, what's the probability that it's going to be a girl at the head of the line? Omar. 11 out of 19. Good. 11 out of 19. Okay, so I chose a girl. That means I'm going to take one girl away. I'm going to subtract a 1. And I'm now left, for my second round of choosing, I'm now left with 10 girls. I still have 8 boys because I didn't line a boy up yet. And I now have 18 students to choose from. I have 18 students to now choose from. I want to pick a girl again. What is that probability now going to be? Mylin? 10 over 18. And then we just multiply. Again, you're going to want to use your calculator. It'll simplify it for you. You're going to get 55 out of 171. 55 out of 171. All right. I'm going to have you guys try this one on your own. We have a basket of fruit. The basket of fruit's got 5 apples. It has 3 bananas, 10 strawberries, and 2 oranges. You're going to pick a fruit. You're going to eat the fruit, which means it's now officially removed. It's gone from the pickings. And then you're going to pick another. You're going to pick a second fruit. So I want the probability that they're both apples. What's the probability that both fruits are apples? Go ahead and do that one on your own. All right, who can tell me what they got? Omar? Not quite. Jose?
1 over 40.
Not 1 over 40. Trey? 1 over 19. All right, let's take a look because we've got some answers all over the place, okay? So, the first thing that you want to do, you want apples for both. You want apples for both. So you know that you're going to have probability for apple. And then you're going to have a probability for apple again. We got to set up the map. Okay? For round 1, you've got 5 apples. You have 3 bananas. You have 10 strawberries. You have 2 oranges. So you have a total of 20 fruit. You have a total of 20 fruit. So the probability that round 1 you're going to pick an apple, that's 5 out of 20. Okay, so I grab an apple. I eat the apple, so I'm taking one away. And that means I now have 4 apples remaining in my second round of fruit. I still have 3 bananas. I still have 10 strawberries. I still have 2 oranges. My total has changed though. Because I took an apple away, an apple is part of the fruit. So the apple, the total is also going to decrease by 1. That's 19. When in doubt, add these up. You're going to get 19. Now we do the probability for another apple. Well, I've got 4 remaining out of 19. Then I just multiply. 5 over 20 times 4 over 19 is going to come out to 1 over 19. Are there any questions? Okay, you are going to go ahead and get onto Google Classroom. You have 2 IXLs. The first IXL link is just identifying if the scenario is independent or dependent. The second IXL link is finding the probability for independent or dependent events.